Welcome all to today's ASRG World Webinar. We have the 29th of April 2021 and we are streaming from Stuttgart in Germany. Thank you for being with us. My name is Sven Schran and I'm your host for today, and I'm coordinating with ASRG the European locations. The Automotive Security Research Group is now nearly 4 years old, and we are a non-profit organization which provides a platform for the automotive security industry as well as related academics or organizations to share knowledge, build powerful networks, and valuable collaborations. This community is for you and it is based on volunteer support. If you want to know more about ASRG, please check out our webpage at www.asrg.io. Send us your questions via email at hello@asrg.io or follow the links in the description below this video. Maybe you have an idea for a nice project and look for partners to realize it. You would like to start your own location. You have an idea about a service ASRG could provide, or you know a great organization which could partner with ASRG. We are open to hear each idea you have in mind and would like to discuss how ASRG can support. Don't hesitate and get in touch with me. So this is enough from my side for today, and I don't want to keep you tortured anymore because I'm very sure you are waiting very curious for our main presentation today. Like every time, in case you have questions during the presentations, please write it in the chat window. After the session, we will have some more minutes for questions and answers. And now it's my pleasure to welcome Victor Marginean, the Global Head of Cybersecurity and Privacy at the business unit HMI, and Kamal Kumar Singh, a hardware security expert from Continental. Today, they will present to us We Are as Secure as the Weakest Link, a view on the security supply chain. And now I would like to hand over to Victor and Kamal. Please, the virtual stage is yours.
Thank you for the invite, and thank you for the opportunity to present this to the ASRG community. So, as Sven already mentioned, today we will speak about the view on the security supply chain and try to see how we can make this overall link, that is this overall chain, as secure as possible. So let's start first with an introduction about myself. So my name is Victor Marginean. I was born in Romania. I grew up in a city with one citadel and one Hollywood-like sign. So this is, if there are any persons that are passionate about capture the flag, now is the chance to find out what is the city. I worked for 12 years in telecommunication, cloud computing and AI, most of the time in telecommunication. And the rest of the time in an outsourcing company where I was in charge of the cloud computing and AI for several projects. I was a radio network engineer at the beginning and had several customer-facing roles for Chinese, French, and US customers. And then in 2018, I moved in Germany at Continental Business Unit Human Machine Interface in Babenhausen. I'm now speaking from Aschaffenburg, so very close to the Hessen border. Kamal, can you please introduce yourself as well?
Yeah, hello everyone. My name is Kamal Kumar Singh, and my preferred name is Kashi. I was born in Varanasi, India, which is also known as Kashi or Banaras. It's a holy city full of ghats, temples, spirituality, meditation, and spicy foods. It's a city where everything starts and ends with Shiva and Ganga. For 5 years, I worked on HSM and hardware cryptographic accelerator design and development. And then I worked on automotive and IoT penetration testing for 4 years. And currently, I'm working with Continental BUHMI Bangalore since 8 months.
Thank you, Kamal. Now let's speak a bit about what we do in the business unit Human Machine Interface. So you can see that we are doing basically all the things that have a bit of a display inside the car. So the full digital displays and the display solutions. The head-up displays, the interior cameras, we are still producing instrument clusters, and we are now entering the business of cockpit HPCs and SAUT solutions. Now, how did we start thinking about these presentations? So it basically started with many discussions and many presentations that we see where everybody is claiming the ever increase of the complexity in the software. And we started with one information that we see a lot in the presentations in the last years, the claim that there are currently close to 100 million lines of software code. This is a claim that was done actually in 2009 by Professor Manfred Breuer, a professor of informatics at the Technical University in Munich and the leading expert on software in cars. What struck me, and I did some research about this, that this statement comes from 2009. So you can imagine the evolution of the software in the meantime, and that it's even more complex and it's even more important how we handle this security supply chain. So now, can we really know how many lines of code we have in a car? I think the easy answer is that we probably don't know. I guess we can spend a lot of time to investigate and to try to find out how many lines of code we really have. But I really think that this is not the point in what is happening currently in the automotive market. And with this in mind, we need to focus on the ever increasing complexity that I was speaking about and the unknown factor. So as you can see in this oversimplified view, basically each car and each product that we have now in the automotive market has some kind of third-party software inside that is then taken over by the tier 2 software providers. There are a lot of them on the market providing also security deliveries, security software, and also any other kind of features. There are also then the tier 2 hardware providers that are also embedding softwares from several other third parties. And then this software is then taken over by the tier 1s that are including it in the ECUs. So now imagine that in a car you have between 80 and 100 ECUs, and each of them will have, beside the tier 1 software inside, they will have also the tier 2 software with all the features, with all the knowledge, and with all the intellectual property that is inside, and also the third-party software, sometimes including even open source software. So it's clear that each of this chain, from this supply chain, is increasing the complexity and the risk of an unsecured chain. Because if you have a vulnerability here in the third-party software, and this is included in the hardware that you are using in your ECU, for sure you will have it also in the car. And if you want to fix it, you will need to spend all the time to get back to that third-party software, and only to investigate and to identify from where is this vulnerability, it will take time. So that's why this really needs to be properly handled, and it needs to be properly tested. Now, having a more detailed look on the complexity, we can see how it actually looks now in a car. So again, you have the third-party software, you have the tier 1 that is providing software, you have another tier 1 that is providing maybe hardware and software to this car network. You also have the OEM who is providing the software. Sometimes the OEMs are providing software to the tier 1s who are just integrating it and providing it back to the car. Sometimes the third party, which is then providing it to the tier 1 and then comes back to the car network. So it no longer looks like something that you can actually control by a simple way of doing it. It's clear that you need behind the process to support it. Because again, just imagine the scale of this and the fact that there are 80 to 100 ECUs, each of them with software inside, each of them with the potential to have hundreds of different third parties and different features that have been developed by developers that were put under pressure, that had to take decisions in the night before the delivery, and those decisions may not always be respecting, for example, the MISRA-C secure coding guidelines. So then, what do we do in order to make sure that each link from this chain is actually secure? So it's clear that you can only do this by making sure that each link is properly tested, because otherwise, if a link is broken, as you can see here, you get it gets messy. You lose the fun, because as in a bike, if your link if your chain is broken, you can no longer ride with your friends, you can no longer visit the place that you are planning. And if you make a parallel with the car, if a vulnerability is there in the car, your car will no longer work. An attacker can do different stuff on your car. They can control it, they can take advantage of it, and then for us, for the suppliers, it will become really messy. And then the only way to fix it is by getting your hands dirty. And the reason why we wanted to do this presentation is because with the UNECE regulation, we see more and more that even if the OEM has to do the homologation, the supplier is relying a lot on all this chain. And the sooner each link from the chain is fixing the problems and is being able to fix the vulnerabilities before delivering the software to the next layer, it's better for everyone in this chain. So that's why this was the reasoning behind we wanted to come and to provide this information that we have to the community, and hoping that like this each link from the supply chain can improve their deliveries. So basically, from what we know, what do you need to do so that you can make sure that all the work products that you need to deliver for security are properly created and tested, are listed here on this page. So basically, and that's why I put it with 0, the software that you have in the processor Bootrom, and I will have another slide on this one, is, I think, the most important thing that you have in an ECU. And I can explain this by the fact that if there is a vulnerability in the software that you have in the Bootrom, and if you discover it too late, then for sure you will need to replace the hardware. And this is then very costly for everyone. It's costly for the OEM, it's costly for the supplier, it's costly for the hardware producer. Beside this, it's clear that you need to do requirements analysis. We are all in automotive business working with requirements. We receive requirements from the OEM, then the tier 1 is creating requirements for the tier 2, and so on and so on. It's always you always need to make sure that the requirements are properly analyzed. Then, of course, you need for security, so that you can have a clean and good basis for whatever you do afterwards, you need a threats and risk assessment done properly, and in order to find all the possible threats that maybe during the requirements analysis you didn't discover. After that, and I think I already mentioned about this, about the coding guidelines and the dedicated checkers, these tools need to work fast, they need not to show false positives, and they need to actually support the developers so that they can quickly check and that they can quickly fix whatever they find when they run the tools. So coding guidelines are needed, and checkers are mandatorily needed, because otherwise the coding guidelines will not be respected. Then, because in more and more projects, open source is being used, you need proper tools for doing the scanning, and these need also to be ensured that can be done in the entire link, so that you don't discover too late that you have some software that you cannot use. Then you have, of course, the conventional functional security testing, making sure that the requirements are properly tested and that they are properly implemented. The next step would be then that you are performing some fuzzing, so running some mutated data, some randomized values on the code and on the protocols that you are using, and even on the binaries, because we see this more and more. And I think it was always like this in the automotive business, that each supplier is using intellectual property when they develop, and then it's normal that they want to protect it. But then for the security side, it means that you will be handled a binary from a supplier that you have no way to know what it's inside. And you have no way to really check for vulnerabilities unless you are doing this binary fuzzing. So Kamal will also show some tools that can be used for binary fuzzing. Then, of course, in order to prepare for the penetration testing and to get to know more about what you deliver, you need, of course, reverse engineering capabilities so that you actually check what you have inside. And then the last step for production, before production, is this penetration testing that you need to do at the end. Kamal will also explain what tools can be used for this. And the most important thing is that that's why you need all these other tools, all this code fuzzing, this protocol fuzzing, these binary fuzzing tools, so that in the moment when you start the penetration testing, you have, I think, a more clean and a more, how to say, more secure product, and then you can only focus on the problem that can come from system integration and then from putting together several softwares. One important thing about what Kamal will show in the second part of the presentation is that we are just presenting the features. We are not endorsing them in the tools. We are not endorsing them in any way. It's just a study that we did on the tools that can be used for the different stages. So take it as it is. It's just our contribution to the community. And now I will start with the Bootrom. So the check that I was mentioning, that from my point of view is mandatory and it's very important. But first, let's make sure that we all have the same understanding on what the Bootrom is. So the Bootrom is the small piece of mass-chrome or write protected flash that is embedded inside the processor chip. It contains the very first code, which is executed by the processor on power on or reset. And you can understand that vulnerabilities inside the Bootrom cannot be fixed with software updates, usually. Therefore, it needs to be thoroughly checked via secure code reviews that need to be done for each product. And with an idea is to do the fast testing of the Bootrom software. I think we've all seen in the last years several vulnerabilities that were announced by Apple, by IBM, by Intel, showing that they have vulnerabilities in their hardware that they cannot be fixed. And they are just letting everyone know that they exist. And as already mentioned, the additional complexity usually in this kind of checks is that the suppliers are not providing that source code. So the only way to do it is to go into a collaboration mode with the hardware supplier, discuss with them, plan a secure code review, and then try to improve the Bootrom. And it's a two-way communication. It's clear that the suppliers are not always happy. I think no developer is happy to show his code and to be reviewed by someone else. But it's clearly something that is needed, because all the fancy features that we are putting on top, all the intrusion detection mechanism, all the other features can just be disabled if you have a problem in the Bootrom. So I think that's all with this slide. I will now hand it to Kamal to continue with the tools presentation.
Thanks, Victor. Now let's discuss about the tools which we are going to use in the 8 stages what Victor just now showed in the previous slide. So the first stage is the requirement analysis and the tracking part. So since requirement engineering is security requirements are the very important in the security engineering process, If one of the requirement are missed from the analysis or implementation, then either it may cause a huge amount of time and effort for replanning the secure feature and development, or it may also lead to a serious vulnerability which can affect the company business. So it is really important to trace each and every security requirement till production. Here are the few tools which we have listed down for this requirement analysis. These are IBM Rational Doors, JAMA Softwares, Visio, and Requisite RM from Oceano. In these tools, we can add the requirements given by the customers. We can link it with the technical requirements, concept designs, test plans, and test cases. These tools are generally used for the requirement analysis and the requirement testability. Apart from these tools, there are other project management tools listed here like Jira, ClickUp, Binfire, Pivotal Tracker. These tools are generally used to create the work products or work packages based on the concepts, and it will be tracked during the throughout the product life development life cycle. These tools also facilitates like showing the abstract status of the project or work products, or collaborating using the discussion forums. Yeah, Victor, please change the slide. Now let's talk about the threat and risk analysis part. TARA is an important process which can get all the possible risk involved in the product along with their severity and the criticality. But threat modeling is a very important step followed during the TARA. It provides all the list of threats along with their impact parameters. So here we have enlisted few tools which can be used for threat modelings. The first one is ANSYS Medney tool, which works on a stride model and take a data flow diagram as an input. Similar to the ANSYS Medley tool, OWASP Threat Dragon and Microsoft Threat Modeling tool also take data flow diagram as an input parameter and create threats based on stride model. Kairos is another tool which works on the DFD data flow diagram as an input, but it uses the attack tree model to derive the threats. The threat modelers also take the DFD as an input, but it uses a vast threat modeling tool. The vast threat modeling method. Thresile, it is a bit different tool which take asset along with their use cases as an input in a YML file, and then it will automatically create the DFD and derives the threats. Here, agile threat modeling with the predefined rules are used. Please change the slide. Now let's come on a coding guideline. It is also very important to remove the vulnerabilities due to the poor coding practices and insecure API uses. So we have to ensure the best coding practices as per the standards. For the code compliance with respect to the standards like MISRA, AUTOSAR, NASA, CERT, CWE, DISA, and OWASP, below are some tools enlisted. Clockwork, CPP Check, S-Tree, Helix QAC, LDRA, Coverity, SonarCube, and Parasoft. Based on the programming languages like C, C Sharp, C++, or Java, and standards which we want to be compliant, we can choose the corresponding tools. Please change the slide. For the software composition analysis, we have Black Duck by Synopsys, Checkmarks, White Source, Fossa, and Veracode. These tools are used to ensure open source security and license compliance in the application and container. As like Victor told, it may happen that some of the software may contain some open source code, but we don't know. So using this type of tool, we can analyze and see what are the open source components are there in our code. Please change the slide, Victor. Now let's focus on fuzzing. First testing is performed to detect and eliminate the memory-related and exception handling issues. For fuzzing, we have enlisted some of the tools here. Peach Fuzzer. Peach Fuzzer supports API fuzzing and network fuzzing, network protocol fuzzings. Defense6 Fuzzer supports files and network protocol fuzzing. For all secure, they have two modules, Mayhem for code, which is used for the code fuzzing, and Mayhem for API fuzzing. Code intelligence tool supports network fuzzing and code fuzzing. Now we have open source tool AFL, which can be used for code fuzzing, as well as there is AFL Unicorn, which can be used for binary fuzzing. We have Mutiny and Bootrom tool, which are the network protocol fuzzer. So based on our requirement, like which protocol to fuzz, or whether we need code fuzzing or API fuzzing or file fuzzer, we can choose the tool. The tools can also be chosen based upon what type of test cases it is generating, or what type of monitoring method they are using, or how much it is easier to integrate our own external instrumentation. So these are the parameters through which we can decide which fuzzers to use. Please change the slide. Now we come on the reverse engineering side. For reverse engineering, the only motive is to find confidential data or a buggy code inside a decompiled binaries. For reverse engineering, we have enlisted Idea Pro, Binary Ninja, Gidra, Radare 2, and Hopper. There are various other tools for reversing, like reversing Java or Android, but we have enlisted only few which support C and C++. So based on the hardware platform, decompiler support, we can select which tool we want to use. Please change the slide, Victor. Now it's a final stage of testing. So penetration testing is a process of identifying the vulnerabilities in the system which can be exploited by an external or internal unauthorized attacker. Penetration testing must be performed on the production device because it is the only testing that is performed on the whole system, and it helps us to find the complex security vulnerabilities and architectural flaws of the system. Here I have listed some tools, but there are thousands of tools available for penetration testing. So let's have a look on the tools that I have enlisted. Hashcat, it is a password recovery tool. OpenVAS is a vulnerability assessment tool which can scan the entire operating system and provide you all the vulnerable configuration policies and CVs available in this operating system. PrivSec check is used for privilege escalation vulnerabilities check. OpenOCD is used for OpenJTAG to audit a security audit for the JTAG. Metasploit is a threat hunting framework which is used to probe the systematic vulnerabilities over the network. Magnet and volatility. Magnet is used to extract the RAM contents from hardware, and volatility is used to analyze the RAM data to find a confidential information like keys or private keys or certificate or maybe some other passwords in the RAM data. Aircrack NG tool is used for Wi-Fi auditing. Nmap tool is a network scanner which is used to find the vulnerable services running over the network. Wireshark is a packet inspection and analyzer tool. GNU radio is most widely used for RF communication. So while doing the custom RF security audit or GPS security checks, we use GNU radio. And Burpsuit, it is a proxy-based tool used for evaluating the security of web applications. And now in the last, even if you use 1,000 tools, we still require a manual testing because not everything can be automated. I think that's all from my side. Now I am handing over to Victor.
Yes. So thank you, Kamal. We end up now with the latest slide, last slide that we have. showing that we're in this together. So whatever one side does, if we don't have the entire supply chain secured, it will for sure we will for sure have a problem. We discussed about the product complexity, and we already showed how complex and how hard it is to make sure that the security is really ensured for the entire car network, because as we said, the software can come from several parts, from several suppliers. Sometimes you as a tier one, you don't even know what software is received from a third party supplier, because they are also using their suppliers that probably are using some open source software. So we need to fight a lot with this unknown of what we actually get in the end in the software. And for this, it's clearly that you need to use a lot of tools. And as you can see, the complexity of the tools, even if they were presented in a really fast way, uh, there are a lot of tools just that can be used for security. And I used here a bit of an IBM Pollyanna principle, adapted to what we need in security. The IBM Pollyanna principle said that machines should work, people should think. I think in our case, as Kamal also mentioned, tools should work. There are a lot of tools that we can use in security and that can be integrated and that will make the developer life much easier. But we still know that people should think, and they should make use of these tools, and they should be able to take the decisions in the end. So as I said, we're in this together. We are providing this to the community, all the tools and structured for each of the different steps that for sure will be needed in each project where the OEM will request the car to be homologated also for the UNECE Regulation 155. It's clear that all these tools will be helpful for one, I don't know, third-party supplier that doesn't know how to start with this regulation. A third-party supplier who makes sure that each of the links and each of the softwares that they have in their deliveries are properly tested using some of the tools that we provided here will make it easier for the entire upper layers of the supply chain. So with this, I think this would be my last words. Tools should work. People should think. Use them, and let's make a secure supply chain for all. Thank you, Sven. I think this is what we had prepared for today. Now we are really open for questions.
Okay, so first of all, from my side, thank you to share with us these insights and your ideas, how you handle the problem. I have a first question related to the tools itself. So what I have seen is a big mixture of different tools, and it's also not so easy to understand in deep detail every of this tool. So this costs also some effort for a company. And then with this background, my question go in the direction: is it the case that you in your development division use every of these tools, maybe dependent on the use case, or is it only that you have had a deeper look in the tools and reduce the amount of tools you are really using in your projects?
So we are not using all of them, and it's clear that you don't need to use all of them. But I think that it's a good start for each supplier to start by analyzing them and then select what fits their need.
Okay.
If we speak about penetration testing, and I will let Kamal speak here because he's the expert, for sure that you will need to use most of them. But it really depends on the use cases. Even if you speak about fuzzing, it depends also what agreement you have with the OEM. Should you do protocol fuzzing? Are they already requesting code fuzzing? It really depends always about what the OEM wants and what you need to do so that you feel comfortable that you don't have vulnerabilities in your software.
Okay, thanks for that. We received a question from Scott, which is also interesting, I think. So Scott is feeling as tough OEMs know fuzzing is a very good approach, but don't know how to identify which areas to fuzz. The scope of potential targets is really huge if we look on a whole car. Do you have recommendation how can OEM help make fuzzing requirements more specific?
Yeah, it's a good question because we also see from OEMs that they want to have fuzzing. They have it somehow in the requirements, but they don't clearly state which kind of fuzzing do they prefer. Do they prefer protocol fuzzing? Do they prefer code fuzzing? Do they even think about binary fuzzing? What we've seen that it works is that as soon as you manage somehow to do it on one project, and then they see the benefits, for example, on the code fuzzing, and they understand how many potential vulnerabilities there were in the software, I think they will probably put it in the next project. But it's I think it's there a learning process. It will not happen from one day to the other. But as soon as you show results, I think they will really want it.
Mhm. I agree also with my experience, and it's a little bit similar like with the penetration tests. So it's also in the projects a hard discussion about the scope of penetration tests, because
Mhm.
if you really want to test everything, then you can never end with it. But there will come the SOP where the cars needs to go to series. So I think it's a similar discussion.
Yes. One problem that we see recently is that even if you do a penetration test at the end, you usually need to do it, as Kamal mentioned, with the device that you hope that will go in production. And after that, you
Yes.
have a limited time to fix then the problems. So I
Yep.
think this can also be a way to explain it to the OEM that fuzzing is needed, because if you remain with a lot of bugs, vulnerabilities, call them as you want, then it will be really hard to fix them before the SOP. And then you will need, of course, to enter in a negotiation. What do you fix for the SOP? What do you fix in a later stage?
Yeah. There is Dylan as a participant today, and he is curious if there's a reason why side channel attack tools was not mentioned um, in your tool presentation.
I will let maybe Kamal answer this one.
Okay, so side channel attacks we have not integrated in our presentation because of its complexity. It's a very complex process. It required huge amount of investments and huge amount of research and effort also. So that is not a easy field. Whether you install one tool and everything is going good, and then we get the results. So only a well expert and well researched company can use that kind of testing, as well as uh, I do believe that it depends upon the uh, level of safety security we want on the system. So as a company we are creating a ECU. I believe it's a moderate security devices. So I really don't feel the need of this side channel attacks here.
Okay, thanks for that. Then the next question is go in the direction you mentioned. You can have up to, for example, 100 suppliers which deliver to a car. And you as a ECU provider or an HMI provider, you have for sure also some suppliers which deliver components to you. Do you have a recommendation regarding the documentation about test results, for example, or do you define a format how the supplier should deliver this to you so that you can compare it between the suppliers and can aggregate it to a documentation from yourself?
We don't have it in this way. So what we are requesting and what we are doing with the suppliers that we work with, we are more interested to see that they understand the process and why it's important. For example, we are asking them to already do a TARA because they know their device, they know how what the problems are on their device. So I think that going more in the direction of a process and making sure that they take care of all these steps, because then they can start also understanding the problem. If we just request from them a report, a test report with a template, they will give it, everything will be perfect. If we
Mhm.
enter in a kind of conversation with them when they really understand it and know, and believe me, after you need to update the Bootrom once and you feel the pain, then you understand that you need a process and that there is no other way. And that's why I believe that understanding that this entire process that we are doing at the OEM, at the tier one, will need to be replicated in some ways at the suppliers that are providing software. Otherwise, just requesting them a report they will send us exactly what we need, but they will not really understand the pain and what needs to be done to generate that report and what needs to be done to make sure that there are no vulnerabilities inside.
Okay, thanks for this explanation as well. I agree with you that it's also important to explain why we request this information, for example, from the supplier.
Mm-hmm, mm-hmm.
Okay, so up to now, we don't have more questions from the participants. So that's why I would say we can come to an end. I will give you the chance to say some final words to the audience.
Yes, so from my side, I please get in touch if you feel that there are other tools that we missed. Please get in touch if you think that you have tools that can support. Please get in touch if you have ideas on how we can better deliver secure products. So from my side, this is a open hand. I don't know how to call it for collaboration. I believe that we can only do this together as a community, as an entire supply chain that communicates while somehow managing to protect the intellectual property.
Okay, then thank you again for the final words and also for the insights, the presentation, and also answering the questions. From my side, also to the participants, thank you that you were be with us again today. I hope you have seen the planned presentations for the next week, and I hope we see us again. And thank you for participation. Until next time. Bye bye.